We're going to use the definition of the derivative to differentiate f of x equals to sine of 10x. Now recall the definition of the derivative. F prime of x is equal to the limit as h approaches 0 f of x plus h minus f of x divided by h. So we're going to do this in a series of 4 steps, but before that, here are the results that we're going to need along the way. The first one is the limit as y approaches 0 of sine y over y equals 1. This result was derived in an earlier video. The second result is the limit as y approaches 0 cosine y minus 1 over y equals 0. This result also was derived in an earlier video. And result number 3 is the trig identity. Sine of a plus b equals to sine of a cosine of b plus sine of b times cosine of a. So let's begin with the first step to differentiate this function. Step number 1 is f of x plus h. We want to express the new function f of x plus h from the old and simplify as much as possible. So this becomes sine of 10, and make sure you put in parentheses x plus h. If we leave out parentheses, this will be 10x plus h, which is not true. So this is now sine of 10x plus 10h, and we can use the trig identity right above to express this as sine of 10x times cosine of 10h plus sine of 10h times cosine of 10x. And that's as much as we can do. And now we can go on to step number 2. Step number 2, we're going to take the function f of x plus h we just computed and subtract the original function f of x. So this becomes sine of 10x times cosine of 10h plus sine of 10h times cosine of 10x minus sine of 10x. Notice that this term has sine of 10x and this one does also, and we can now factor out sine of 10x with those two terms. So this becomes sine of 10x times cosine 10h minus 1 plus sine of 10h times cosine of 10x. That's the end of step 2. Let's go to step 3. Step 3, we take f of x plus h minus f of x and divide that by h. So all we're going to do here is take the end result of step 2, which is sine 10x times the quantity cosine 10h minus 1 plus sine of 10h cosine of 10x and divide all of that by h. There's nothing more that can be done. The derivative will be computed once we take the limit. So step number 4, actual computation of the derivative f prime of x is equal to the limit as h goes to 0 f of x plus h minus f of x divided by h, and this becomes the limit as h approaches 0 sine 10x times the quantity cosine 10h minus 1 plus sine of 10h times cosine of 10x. Divide that by h. The best way to evaluate this limit is to break it up into a sum of two limits. Since h goes to 0, x is unaffected, so we can take sine of 10x out in front of the limit times the limit h approaches 0 cosine of 10h minus 1 over h plus cosine of 10x, that doesn't have any h in it, times limit h approaches 0 sine of 10h divided by h. Now we need to do one more thing. Because we have cosine of 10h and we have only h in the denominator, we're going to multiply both limits by a form of 1, which is 10 over 10. So times 10 over 10 and times 10 over 10. Here, the 10 in the numerator will filter outside the limit. So this becomes 10 times sine of 10x times the limit as h approaches 0 cosine of 10h minus 1 over 10h plus 10 times cosine of 10x times limit h approaches 0 of sine of 10h over 10h. Let's make the following substitution. Let y equal to 10h. So note that as h approaches 0, y equals 10h also approaches 0. So we can express each limit as first 10 times sine of 10x times the limit y approaches 0, and now this is cosine of y minus 1 divided by y plus 10 times cosine 10x times limit y approaches 0 of sine of y divided by y. Now let's use results 1 and 2. This first limit right here, this limit goes to 0, and the second limit here goes to 1. So 10 sine 10x times 0 will be 0. 10 cosine 10x times 1 is going to be 10 times cosine 10x. So this is equal to 10 times cosine of 10x, which is our derivative. To summarize, if f of x is equal to sine of 10x, we just use the definition of the derivative to show that f prime of x is equal to 10 times cosine of 10x. For more videos, visit www.mathprepvideos.com.